Good evening, everybody, and welcome to the latest installment of our EcoFlora virtual seminar series. My name is Lydia Paradiso, and I'm a doctoral student at the New York Botanical Garden and a graduate fellow with the New York City EcoFlora project. EcoFlora is a community science project with three main goals: to investigate urban ecosystems and urbanization, to support open source biodiversity data, and to increase the understanding and appreciation of plant life. To date, over 30,000 observers have made almost 1 million observations of over 12,000 species of plants and their biotic partners in New York City and posted them onto iNaturalist. You can explore the observations on our project page, which I will link in the chat. Each month, we sponsor an EcoQuest challenge, which encourages New Yorkers to observe a particular species, group of plants, or interaction and post those onto iNaturalist. Our June EcoQuest is all about apiaceae. Also known as umbellifers, members of the apiaceae or carrot family have flowers arranged in umbels, which are flat-topped clusters of flowers that radiate from a single point at the terminal end of the stem. This family has many well-known edible species such as carrot and parsley, as well as toxic species like poison hemlock and phototoxic species such as giant hogweed. With nearly 4,000 species described worldwide, there are 18 species with research-grade observations from the month of June on iNaturalist in New York City. So for this month, our goal is to see if we can find those, all of those, or even more. You can see all the observations for this EcoQuest on the page on iNaturalist, which I will also throw a link in there. If you want to receive emails from us about upcoming virtual lectures, in-person events, and future EcoQuests, you can sign up for our mailing list. And now I'm going to hand it over to Tomi to introduce our speaker.
Good afternoon, everybody. Before I introduce our speaker for tonight, I want to begin, per usual, with a land acknowledgement by recognizing the original people of this land, the Lenape, as well as their deep connection to the Lenape-Hoking homeland, which is an area including New York City. As a representative of an organization dedicated to advocating for the more than human world, it is imperative to acknowledge the original stewards of this land, the Lenape, as well as the settler colonial genocide perpetrated against them and in other indigenous communities. It is also important to recognize the resilience of the Lenape and all indigenous and First Nation communities who still today continue to resist that erasure. Okay, so our speaker tonight is Dr. Peter Groffman. He is a professor at the City University of New York, Advanced Science Research Center, and Brooklyn College of Earth and Environmental Sciences. He's a senior research fellow at the Carey Institute of Research Sciences. Dr. Groffman's research focuses on climate effects on ecosystem biochemical processes related to carbon and nitrogen cycles. He was a convening lead author for the 2013 U.S. National Climate Assessment Chapter on Ecosystems, Biodiversity, and Ecosystem Services, a lead author for the second Wetlands and the third North America Assessment reports of the Intergovernmental Program on Climate Change, also known as the IPCC, and is on Reuters' hot list of the world's top 1,000 climate scientists. Tonight, Dr. Groffman will talk to us about green infrastructure. There's a great current interest in the creativity in the creation of green infrastructure to address a range of challenging and expensive environmental problems, from coastal resilience to control of combined sewer overflows. The appeal of green infrastructure is that it is often less expensive than traditional constructed gray infrastructure, and it provides multiple benefits such as biodiversity, aesthetics, and carbon sequestration. However, while highly engineered gray infrastructure has detailed design specifications and reliability specifications, these are largely underdeveloped for green infrastructure. In this talk, Dr. Groffman will review some of the potential applications of green infrastructure in modern environmental science and discuss how concerns about reliability need to be addressed to realize the potential of this new approach. Okay, so throughout the chat, please feel free to enter any questions or comments into the chat as we go. At the conclusion of the talk, we will go through as many questions as we are able. If you have a question or comment that you would like to ask verbally at the end of the talk, you can use the raise hand feature or note in the chat, and we'll unmute you, and you can unmute yourself, and you will have the opportunity to do so. Also, if you are unable to stay for the whole talk or you would like to share it with others or watch again, a recording will be posted to the New York Botanic Gardens YouTube channel in the EcoFlora playlist. And I think Lydia is going to link those in the chat now. So now I am going to hand it over to Dr. Groffman.
All right, thank you. I am just delighted to be here. I was so excited to find out about this group, that there's a group studying spontaneous vegetation in cities and doing it with a community science approach. That to me is very exciting. And so I'm very glad to talk with you today. And in particular, this topic of green infrastructure is just a super important topic, and one where we need people who like to think about plants in a creative way, and spontaneous plants, and what plants grow in the city, and what can we do with them and what we can't do with them. And so I think this is a fun topic, and I'm just very curious to get, to throw out some ideas and then get some feedback from you all. And so the title of my talk is how reliable is the green infrastructure? And I'm going to strike a couple of themes. So one is this first idea that green infrastructure is a super exciting topic now. There's this tremendous interest in the idea that we can use green spaces in cities for a variety of purposes. It's stimulated this great burst of creativity amongst designers and managers and municipal agencies, and so it's an exciting topic. And I think also the things that we're grappling with green infrastructure, this interface between design and science and soils and plants and communities, is very central to much of what we're grappling with in urban ecology now, and certainly central to this idea of spontaneous vegetation in cities. There are a couple of motivating contexts. There are a couple of things that kind of keep me up at night, and I'm hoping if I could share them with you, they can keep you up at night as well, so I don't have to be the only one up at night. But so in a certain way, I feel like I'm the dog who finally caught the mail truck. I don't know if you're all familiar with the mail truck comes down the street, the dog goes running after the mail truck, and you wonder, like, what would the dog do if it actually caught the mail truck? And as an ecologist, I have been advocating for the use of natural ecosystems and the natural processes in soils and vegetations to solve many of our environmental problems, from cleaning the air, cleaning the water, to improving mental health and physical health, solving nature deficit disorder amongst our children. We've been sounding the, making the case that there are lots of natural processes that we can use to address compelling problems. And now, with the advent of green infrastructure, society's looking at us and saying, okay, do it, right? So we're gonna give you billions of dollars for green infrastructure to solve combined sewer overflows and to moderate the temperature and the air quality and the water quality in cities. And so now it's time for us to deliver, and it makes you nervous. So I grow lots of plants in my yard, and many of them die. And so suddenly now, if I'm going to be using those plants to do specific things in green infrastructure, I'm worried about that. And so this is it's a really important time for us in environmental sciences to kind of rise to the occasion. The other big motivating context, which I think which I'm going to talk about a little bit, is the idea of extreme events. And in New York City, we're pretty good focused on extreme events because in 2012, Hurricane Sandy came and kind of whacked us on the back of the head and flooded our city. And so we're keen on extreme events. And there's this real kind of overarching question about, is this green infrastructure, maybe it works great on a nice sunny day, but when we get an extreme event, are we creating a vulnerability by relying on green infrastructure? It's my neighbor always wants to know, when am I going to fix my leaky roof? Well, it's working fine today, and when it's raining, it's too wet to fix, and so I get nervous about that. And so those are the themes I'd like to strike. This is an exciting topic. It's a state-of-the-art topic, so there's lots of research uncertainties, and there are some really important motivating contexts. Okay, so let me get my fancy pointer going. Okay, so here's an outline of the things I'd like to talk about. First, I'd like to spend a little time talking about definitions. What is green infrastructure and how those definitions have evolved over time. I then talk about a couple of examples of projects where we've been assessing, does green infrastructure work to do what we think it's doing. A little bit of work on developing assessment protocols to to come up with a system for evaluating variation in time and space and how well green infrastructure is working, and then ending a little bit with some discussion of extreme events in the context of Sandy coming back. So I've been very lucky to work with, and I'm going to highlight the work of a couple of graduate students and postdocs throughout here. So one postdoc, Z. Grabowski, who's a postdoc at the New School, was really puzzling over these wide range of definitions of green infrastructure in the literature. And so he did a little bit of a kind of a synthesis of different ideas of green infrastructure and proposing a new definition that's a more integrative definition. And so if we think about green infrastructure in a certain way, it's a very, very old concept. And in Grabowski's review, he talks about its roots in 19th century landscape design and planting, but it actually goes back much further than that. As soon as there were cities, the people who ran the cities were panicked that the people in the cities were going to go crazy because it was too hot and too noisy. And so there was always a need for green infrastructure. I like to think about Nebuchadnezzar back in Babylonia, going to his sustainability department, saying, the city's too hot and it's too dusty. And they said, well, maybe you should build a hanging garden. And he said, oh, okay, we'll have this. So you think about the hanging gardens in Babylon were probably the first manifestation or a very early famous manifestation of green infrastructure in cities. And so we've always had a need for green spaces in cities. And over time, people have recognized that if we're going to have nature in cities, it's going to be a mixture of natural systems and human engineered systems. And so that was evolving for thousands of years in cities. But there was a big change in 2007 when the Environmental Protection Agency said that you could use green infrastructure to comply with the Clean Water Act provisions for capturing stormwater. So we have lots of stormwater moving through our streets. It drains into our sewer plants and causes our sewer plants to overflow. And all cities have got to comply with this Clean Water Act and have a stormwater plan. And so that was a huge change, and it stimulated this huge burst of creativity. Suddenly, all kinds of people, whether it was landscape architects or designers or artists or engineers or regulators, everyone said, this is great. We can use these approaches to solve our stormwater problems and then also provide all these other ancillary benefits. So how is this specified, right? So Section 502 of the Clean Water Act says you can use plants and soils and all kinds of kind of combined natural engineered features to capture stormwater and to store it or infiltrate it or somehow just keep it out of the sewer system and keep it out of the ground. And there's this important distinction between gray infrastructure and green infrastructure. So gray infrastructure is pipes, and that's been the traditional approach. Is I collect the water off the street and I pipe it somewhere else. And if I pipe it into the sewage treatment plant, then when it rains a lot, I have the sewage treatment plant overflows. But even in cities that don't have combined sewers, you collect the water off the street in a pipe and you dump it into the stream, and it really degrades the stream. So there were lots of drawbacks of gray infrastructure. And so the idea was maybe green infrastructure, we're going to collect and treat the stormwater at its source and deliver a wide range of environmental, social, and economic benefits. And so that's the idea behind green infrastructure. And again, it's just stimulated this burst of productivity. So if you look around you, you see some really cool things. Whether it's these vegetative swales or these planter boxes, or is that my hand that's raised? Let me see. I'm sorry. Let's see. Is that me? I will lower my hand. Sorry about that. Okay, you can see there's green roofs. There are some old-fashioned features like retention ponds, but you see there's a long list of different green infrastructure. And again, it's been an exciting time to develop these approaches. And again, you look at a green roof, people get excited about green roofs, and you can see why they get excited about green roofs. Instead of just a gutter on the roof, I've got a really interesting mixture of plants that provides aesthetic values, but it's also absorbing a bunch of water, and it's cooling the city, and you can see that you get lots of ancillary benefits from these green infrastructure features. Of course, now these are pictures, right? Idealized pictures, and we know what I'm going to talk about today is okay. Now this is the glossy brochure, And then what is the green infrastructure? The question is, how does it really work out, right? And so I'm going to talk a little bit about some of these green infrastructure features you can see in Brooklyn. And again, you can see this is what they look like in New York City. You can see that there's a curb cut here. So these are designed to absorb water from the street, and instead of having it run into the sewer and into the sewage treatment plant, it runs into the street side infiltration swale, and the plants use some of the water, and they infiltrate a lot of the water, and you can see that, you know, you can see the challenge of green infrastructure in a dense urban city like New York. These are pretty small systems. They're in a hot neighborhoods, and it's kind of hard to be a plant in a neighborhood like this. The water that comes off the street is really hot. The water that comes off the street is loaded with hydrocarbons and metals and other pollutants. And so it's not, you know, once you go out and start to look at these things, you see the glossy brochure, you say, yeah, this is great, let's do this. But once you start to go out and look at it, you start to really worry a little bit about, okay, so if all these plants die because it's really hot, will the green infrastructure still continue to function? And so that's kind of the question that we're talking about here today is, are these things really, how reliable is the green infrastructure? How can we assess that? What do we need to do to increase that reliability? And the big driver, this is I'm sure a huge surprise to everyone, the big driver of green infrastructure to many people is it saves a lot of money, right? So this is a figure from the original New York City Sustainability Plan from 2007, which said, okay, we need to control combined sewer overflows. And the combined sewer overflows, I always like to talk to students about what are the three big water quality problems that we have in New York City. We have combined sewer overflows, and combined sewer overflows are our three big problems. And it's no joke, right? So in order to, because we get these rain events, the sewage plants overflow, and then our waterways are filled with raw sewage. And so we have a consent decree with the EPA to control these CSOs, and a great strategy which involves building enormous tanks. I don't know if you've seen these. They're building a new one in Gowanus. I think if you have a chance to go walk along the Gowanus Canal, and you can see the construction for a CSO holding tank. It's 3 football fields long and a football field wide. And it's going to hold a lot of stormwater, but it's expensive. And so if you're comparing a gray strategy with a mixed gray-green strategy, you end up saving several $1 billion in cost, just in total cost. But then also there's this question of, am I going to get a lot of ancillary benefits from the green infrastructure? Am I going to get cleaner air and cleaner water? Am I going to get a cooler city? Am I going to get aesthetic values? Am I going to get some environmental justice out of this? And so there's really big numbers driving interest in green infrastructure in New York City, as well as just a lot of excitement about cool designs. Now, Grabowski in his review certainly was able to pick up that there's a lot of excitement about green infrastructure, but there's a whole lot of confusion as well. So he reviewed plans. So there's all different kinds of plans, right? People have green infrastructure plans, and they have sustainability plans, and they have comprehensive plans, and they have watershed improvement plans. They have all different kinds of plans. And he reviewed the plans in it was about 15 different cities across the United States. So San Jose, Syracuse, St. Louis, Phoenix, Miami. And he said, how many definitions of green infrastructure do you have in each of these cities, right? So Atlanta was the winner. There were more than 20 different definitions of green infrastructure if you peered into all the plans in the cities of Atlanta. In New York, we have about, where's New York? New York is close to the top with about 18 different definitions in the different plans in New York City. And that's really confusing, right? So when people say, what is green infrastructure? It depends. There's 18 different definitions of that in the New York City government plans. And then he also did a cross-cutting analysis. He said, so if I look at all the different green infrastructure plans across the different cities, this is even just green infrastructure plans in different cities, there's about 15 different definitions within those plans. You look at comprehensive plans, and there's more than 30 different definitions of green infrastructure. So there's really a bit of definitional confusion about just what the people mean when they talk about green infrastructure. And it arises from what Grabowski called the green infrastructure paradox. And it's basically the discussion that we've just had, that green infrastructure is green space in cities, that going back to the Hanging Gardens of Babylon, people have always needed this interconnected network of green space that provides some natural ecosystem values and functions for humans in a city. Okay, so that's the traditional old-fashioned definition of green infrastructure. But then there's this the EPA definition where you get the idea that we're managing stormwater. And so you really have, if you want to combine those things, he proposed a new definition which integrates those and says, okay, green infrastructure is a conceptual framework for considering the relationships between ecosystems, the built environment, and people. And it recognizes that interface between ecological and technological elements across scales, and tries to create a more comprehensive, holistic definition, which should allow us to recognize the scope of green infrastructure. And I think it should allow us to address some of these evaluation issues that we're going to talk about as we go forward. So that's a new definition of green infrastructure. And another way of looking at it, so another postdoc that I've been working with, Marissa Matzler, was thinking about green infrastructure along what she called an eco-techno spectrum, or an ecological technological spectrum. And I think this is really useful in a couple of ways, right? So if we think about the scope of green infrastructure in a city, we've got a bunch of natural systems. Basically, we have wetlands and we have remnant forests that are pretty much really strong on the ecological end of things. And then on the other end, you have a lot of things on the technological end. So we have porous pavement, we have these bioswales, which are very engineered and very technological. And this use, so they have a bunch of things that are in between, like parks and street trees and urban agriculture are kind of a mixture in the middle of this eco-techno spectrum. Now, this eco-techno spectrum, I think, is useful for, okay, we're talking to people and we're thinking about what kinds of plants are useful in these different types of green infrastructure features, and it lets us get the scope of green infrastructure. But it also allows us to ask some functional questions, right? So when we think about green infrastructure, we have social questions, we have political questions, we have financial questions. So who interacts with which types of green infrastructure? So what group of people is interacting with these wetlands and remnant forests on the ecological ends of things? What group is interacting with the group of features on the technological? Is there equity? Are there equity issues associated with which groups get to interact with which different types of green infrastructure? There's a political dimension. Who's making the decision about installing green infrastructure or managing green infrastructure or protecting green infrastructure? And does that vary along this eco-techno spectrum? And you suspect that it does, that the people making decisions about wetlands and remnant forests are very different than the people who are making decisions about green roofs and bioswales. And then there's the financial dimension, and who's paying for these features. And as we get really interested in installing features for different purposes, so then the finance question becomes very important, in that who is really interested in building bioswales and porous pavements, and why? Who's interested in protecting wetlands and remnant forests, and why? And so this idea of an eco-techno spectrum helps us to grapple with the scope of green infrastructure, and then also to do some more pointed analysis about who's benefiting, who's making the decisions, and who's paying as we go along. Okay, so that's my introduction to the scope of green infrastructure, and I've tried to be brief about it, but I hope that you get that there's a challenge, but I think we've made progress with our definitions and our scope. There's a lot of questions about how well it works, and I think, you know, I'm going to show you that picture of the green infrastructure in Brooklyn. I think I'm going to show it to you 3 times during the course of this talk, because it really makes you, when you go out and look at some of these features, and I would encourage you all in your neighborhoods to go out and look at the green infrastructure, and some of it looks great. Some of it looks a little sad, and there's just a whole bunch of questions about, does it work? And so I'm going to give some examples from this Urban Resilience to Extreme Events project, and some examples from Brooklyn and Baltimore, where I've done a lot of work for a long time, and I'm going to highlight some of the challenges that we have. So I was involved, and several people at CUNY were involved in this Urban Resilience to Extremes Sustainability and Resilience Network. This was funded by the National Science Foundation. It was a network of 10 cities in the United States and in Latin America, and we were addressing this question of urban resilience to extremes, and what are the challenges in addressing that. The UREX project, or this Urban Resilience to Extreme Events, had a very strong conceptual basis, focusing on cities as what they called socio-ecological technological systems. So when we cast our eye about the city, we've got an ecological and biophysical domain, which is where all the living stuff. We have a technological infrastructure domain where the roads, we have lots of infrastructure in cities. And then we have the social economic domain. And green infrastructure is a classic example of something that sits right in the sweet spot of those three domains. So there's clearly a very strong ecological, biophysical domain for green infrastructure, but there's also a lot of technology and infrastructure involved in it, and it has the social dimension. And so green infrastructure emerged as one of the key integrative topics within this urban resilience to extreme events network, because it really was a great place to focus on how do we integrate between those different domains in cities, which is just, it's a huge challenge. So we did an analysis of green infrastructure in 10 cities across the United States and Latin America, and we came up with 5 challenges that cut across all these different systems. So one is a lack of cohesive design and implementation across silos, and we saw that. You see that there's all this excitement about designing green infrastructure, but there's not a lot of standards or cohesion for the way these things are designed. And as you cast your eye in the city, so in different cities, there's 10 or 20 or 30 definitions of green infrastructure in each given city. So that's going to create a little bit of chaos in the design and implementation. And until we get some standards and some cohesion in the design and implementation, it's going to be very hard for green infrastructure to be successful. The other challenge that emerged is that, and this is I'm sure shocking to everybody, but places are different. And so things that work in one part of the world are not going to work in another, necessarily work in another part of the world. My favorite example is, and I've been lucky over time to do lots of comparisons between Baltimore and Portland, Oregon. And so Baltimore and Portland, Oregon are really interesting because they both have the same amount of rainfall. They both get about 45 inches of rain a year, but it's very different 45 inches of rain per year in these different cities. So in Portland, rains a little bit every day, kind of drizzles on you, and you get 45 inches of rain. And in Baltimore, you have a lot of sunny days, and you have a lot of days with enormous thunderstorms. But green infrastructure works really, really differently. It works really well in the rain in Portland, not so well with the big thunderstorms in Baltimore. And so there's a strong need for regionally specific codes and standards. The other thing that emerged from our cities is not enough attention to environmental justice. And I'll give a very specific example about this in Baltimore. But this is we always we recognize that there are problems that are difficult, and frequently we then turn around and realize that the things that we're doing are making it worse, and that's something we would like to avoid with green infrastructure. And I'll give an example of that, but that also is important across many of these cities. Extreme events, and I'm going to come back and talk about that at the end. Extreme events are just an overwhelming challenge for us. And so we designed a nice bioswale or a nice green infrastructure feature that's designed to work for a small rainfall event, but does it get washed away in a big rainfall event? And that's a big problem. And then this question of financing, of financing mechanisms to get these things done in the places where they're needed are lacking as well. So this is, and I think none of these are probably surprising to people, but if we really want, if we are the dog who's caught the mail truck, we're going to have to resolve these things if we're really going to make green infrastructure work in our society. So let's take a look at some of the work that we've done in Brooklyn, right? So this is work that's been mostly led by Joshua Chang, as a professor at Brooklyn College, in collaboration with the city, has established lots of green infrastructure sites in Brooklyn. And again, here are these pictures that I showed you before. And again, we're asking these sites to do a lot. We're asking these plants to grow under difficult conditions, and we're asking them to live under some pretty difficult conditions. The thing that I always like to remind people about is, so think about on a hot summer day and it rains and the water comes rolling off the street into this green infrastructure. So how hot is that water, right? So the first flush of runoff off a pavement is really, really hot. And so if you're some type of beetle or some type of bug or some type of plant, that first flush of water, you might get cooked in that. And then of course the other things, what else is in that water? There's all kinds of pollutants in that water. And so So there's some real questions about how these systems, which are designed to be connected to the street, how reliable are they? So just a little bit of data. So we were looking at in these work in Brooklyn 3 different types of green infrastructure. These enhanced tree pits, ETP. These are street side infiltration swales, and the VS are vegetated swales. And the ETPs are the ones that are really tightly connected to the street. SSIS are also pretty well connected to the street, and the vegetated swales are more isolated from the street. And so if you look at these 3 different types of green infrastructure, in this graph, this is petroleum hydrocarbons, here's lead in the soil, this is zinc in the soil. And you can see the ones that are connected to the street, they've got lots of exposure to contaminants. The soil is loading up with petroleum hydrocarbons, it's loading up with lead, it's loading up with zinc. And in a certain way, that's good, right? Because there were these contaminants in the water. They're now no longer in the water, they're being sucked in the soil. But what effect does that have on the plants and soil process that we'd like to get in the green infrastructure? And so this accumulation of contaminants is a big issue with green infrastructure. But in our measurements, we see that the biological function of these is maintained pretty well, right? So we're measuring microbial processes. This is the living carbon and the living nitrogen in the soil, and this is the breathing, the respiration of the microbes in the soil. This is the nitrogen cycle in the soil. And you can see that the levels of biological function are quite high in these highly connected, more highly contaminated sites. And so, yes, they're accumulating contaminants, but the biological function is maintained, at least so far. And so this is the kind of interesting science question, but great uncertainty is, okay, how much contamination is going to accumulate in these features? And at some point, will it start to affect their function? That's a research question that we hope to continue. The other question, and we've been doing a lot of work in Baltimore, which has a lot of green infrastructure and is a poorer city than New York, is the question of maintenance. So there's a lot of trash that comes floating down the street. So if you look at these swales, they accumulate trash. You look at the entrance to some of these features and they fill up with natural debris and also with trash. And you can see there's lots of trash that causes the features their function to fail. And it certainly doesn't help maintain public support for these if indeed they're getting filled with trash and failing. And we work in Baltimore. Baltimore's a poor city, so here's a bioswale in a neighborhood in Baltimore, and this is a neighborhood in Baltimore with lots of abandoned houses. And you can see this feature looks lousy. It's got a do not litter sign, and people have really there's a lot of litter in there. They planted a lovely assortment of native plants, and the residents kind of tore the plants out. And these features are unpopular in this neighborhood. And so we're out working in this neighborhood, and people come by and they say, well, what is this? And it's actually not. They say, what the bleep is this? And how much did it cost? And so then we say, okay, to design and construct and implement this feature is about $60,000. And people get angry. $60,000 in this neighborhood. We've got problems with rats and with food insecurity and with education and childcare, and you're spending $60,000 to build this, and then they lose parking as well. And so this kind of hit us pretty hard because we realized that, okay, we're very excited about green infrastructure, but is it taking an area which already has big environmental justice issues and making them worse? And so this is to me is a huge frontier in green infrastructure, and that we've got to be doing community science. It's very glad to, the group, this EcoFlora group, which is doing community science on plants. We have got to be doing community science on green infrastructure. And when it's done properly, people get very excited about these features, and they take care of them, and they become a useful feature in the neighborhood. But if they're just imposed on the neighborhoods, they just make things worse. And again, I think this isn't a big surprise. We've learned a lot about this in the last 10 years or so. But it's very important for us to deal. Okay, so here's my outline. And we've talked about what is green infrastructure, and we've talked about some of the challenges with some of the kind of inherent scientific uncertainties that we have to grapple with to see if it works. The other thing I want to talk about is how can we tell if it's working, right? Do we have some type of assessment systems to evaluate green infrastructure? And this turns out to be quite a challenge. So And I wanted to highlight an effort that was led by the Science and Resilience Institute at Jamaica Bay, which is based at Brooklyn College, which was to develop a protocol for monitoring the natural and nature-based features along shorelines in New York State. Now, there's a lot of interest in natural and nature-based features along the shoreline. Ever since Hurricane Sandy, we realized that we needed to improve and secure our shorelines and increase their resilience. And again, it is very similar to the eco-techno spectrum. If you think about shoreline features, we have a bunch of natural features like natural dunes and natural marshes and oyster reefs. On the other extreme, we have hard structural features like bulkheads and various engineered features. And then we got a whole bunch of things in between. And there's really exciting interest and a lot of money being spent to implement these features across the state. Now the question is, are they worth it? You know, are they working? And we need to know, are they working now? We need to know if they're working over time, and we need to know if they're working in multiple dimensions. And so this creating a monitoring framework turned out to be a really interesting and complex endeavor for us. And so we wanted to create a monitoring framework that needed to meet many criteria. So it had to be a coherent framework that was based on a strong scientific and technical background. It had to have broad buy-in from agencies, from practitioners, from civil groups, and it had to be applicable across all of New York State, which is a diverse coastal environment. So let's talk about some of these challenges here. Right. So now, if I have a natural and nature-based feature, I want it to do many things. I want it to maintain structural integrity of the shoreline. I want it to provide hazard mitigation. But I also want to know, is it providing some ecological benefit? And I also want to know, is it providing some benefit to the community? So right away, I've got a protocol that's got to address 4 very different areas. And so that's a complex protocol to address those 4 different areas. I've also got to have a protocol that's going to apply across New York State. New York State has a lot of shoreline, right? So we think about the ocean and the Long Island Sound shoreline down here, but there's a lot of shoreline along the Hudson, and then there's a lot of shoreline along the Great Lakes. And so this protocol had to be relevant across all those different parts of the state. It had to be a protocol that was going to be accessible to a wide range of audiences. So there are some people that are deep into the technology, whether they're consultants or engineers, academic groups are up on the latest technology, but there are stewardship groups, and there are permit regulators, and there are property owners, and there are community groups, and the protocol needs to make sense to them. We also would like the communities, we'd like a strong community science approach to be involved in this protocol. And so now I've got a protocol that's got to be relevant to a wide range of audiences, applicable to a wide range of environments and a wide range of feature functions, and it's got to apply to all different kinds of projects, right? So there are large, expensive projects on natural nature-based features, and there are small, expensive projects. All these projects seem to be pretty expensive, but it's got to apply to a bunch of different projects. And I don't know how many of you are familiar with the movie Monty Python and the Holy Grail, but in that movie, King Arthur and his knights are passing through the woods, and they run into these fearsome knights who say need. And they say, you cannot pass through these woods, you must return here with a shrubbery. And Arthur says, sure, okay, I'll bring you back a shrubbery. But they said, not just any shrubbery, it has to look nice and not too expensive. And that's indeed the case with these natural nature-based features. It had to be, a very comprehensive and scientifically rigorous evaluation protocol, but then also one that was not too expensive and that could be used by all different kinds of community groups. And so this it's really quite a challenge. And we're left with the question, going forward, and this is still ongoing, is we're building these natural nature-based features. Are they really doing what we doing what we hope they're going to do? Are they providing ecological function, hazard mitigation, and socioeconomic value? Can our framework assess this value? Can I go out there and see if this site is worth really doing what it's doing? And I want to go back every 5 years to these sites, and I want to assess changes in this values over time. And so we're going to go back to the Knights of Knee. We're going to bring them a shrubbery, and hopefully they're going to say, yes, it's a good shrubbery. They like the shrubbery. But this is again, it's an ongoing challenge to evaluate. We really need to know if the green infrastructure and these natural and nature-based features are functioning. So we've got this protocol that we developed, again, led by the Sustainability and Resilience Institute, Jamaica Bay. And this is an old slide. Back a couple of summers ago, we did this pilot monitoring. We sent students all over the state to test a bunch of sites. But we're really trying hopefully to get more funds so that we can just implement this monitoring framework, refine it over time. And then we'd have a tool going forward to know, are we really making some progress with building resilience along our shorelines and in building green infrastructure to provide multiple functions in our cities. Okay. The last thing I wanted to talk about was these extreme events and using Hurricane Sandy as an example. So many of us remember 2012 Hurricane Sandy caused massive damage in New York City. And this question of what are we going to do about it? And we know that Sandy is coming back. Because Sandy's coming back either this year or next year. At some point, Sandy's coming back, and Sandy's going to be grouchy, like a relative that leaves their phone on the hall table at Thanksgiving and then is really angry and comes back to get their damn phone. And so, what are we going to do about it? And this is really perhaps the greatest challenge that we face. I wanted to talk about a couple of things. We have this dichotomy between gray infrastructure, giant flood walls, versus the softer approach with green infrastructure and natural nature-based features. And there are a couple of concepts I think that help us, that I think are worth thinking about, this idea of fail-safe versus safe to fail, and also the idea of managed trees. So this is an old slide, but I think many of you are aware of the idea that Hurricane Sandy sent a wall of water into New York Bay. It went up the Hudson. That wall of water went all the way to Albany up the Hudson, and it created massive damage all the way along. And so one idea was, well, let's just build an enormous barrier across the bay, so that we can prevent that wall of water coming in. And there are all kinds of barriers. You can build barriers around for Jamaica Bay, and you can build them for Jones Beach, and you can build them on the East River. And the ideas for these have changed, but there's an active discussion going about should we build these enormous barriers. And you can see there's the East River one, the Jones Inlet, the Rockaway Barrier, and then there's the really big one, the Outer Harbor Gateway. And the idea of giant flood walls is based on the idea of fail-safe. And fail-safe is an old engineering principle based on risk analysis. You say, well, what's my threat? What's the probability of the threat? What are the consequences of that threat? So I'm going to design some really big infrastructure with a low probability of failure. I'm going to make it oversized, and I'm going to be safe. It's going to be fail-safe. I'm going to be safe behind this giant wall. But of course, the question that emerges now is what happens when these solutions fail? And the idea of big levees and big flood walls is they keep you safe until they don't, and then the damage is catastrophic. And the best example of that was Hurricane Katrina, where there were these levees. There was a false sense of security behind the levees, and when they failed, they amplified the overall damages to the city. Now, so things like Sandy and Katrina have really focused the idea that maybe we need to revisit this whole idea of fail-safe technology, and it's just because the jargon term for it is non-stationary. You know, we can't predict the climate, we can't predict the size of the storms, and we can't predict what happens in cities. Like maybe people will stop coming to work every day. How could that happen? And maybe we're going to get more intense rainstorms. So this idea of it being very difficult to estimate the weather, population growth, social demographics has made people say we need a different approach than fail-safe, because the probability of failure is much higher in a non-stationary world. And so the alternative is the idea of safe to fail. And the safe to fail concept is the idea, can we minimize the consequences of an extreme event rather than minimizing the probability of damage? And so this is a more flexible approach that kind of lets the water come in, but then facilitates the water draining out more quickly. It's a very different approach than fail-safe and big walls, and it requires a bunch of changes in the way our society thinks. So it's much more decentralized, much more autonomous than the centralized hierarchical schemes, and it involves a lot of communication and collaboration within departments, within disciplines, and between communities and municipalities. Now, as an ecologist, again, this is the kind of thing where I feel like I've caught the dog who caught the mail truck. It's like this idea of safe to fail is very appealing as a no-brainer, but is it going to work? Right. So if, and this is a question that we have to deal with in New York is, are the softer, smaller features going to work better or worse than the giant walls? And then perhaps more importantly, will people believe that the softer, smaller features are going to work? Are people going to be happier with a nice sand dune next to their neighborhood, or are they going to want a big concrete wall next to their neighborhood? There's also the question of will the features be distributed equitably? Who's going to get the really nice looking sand dune next to their wall, and who's going to get a pile of mud, or who's going to get a wall? And so safe to fail is a very appealing idea, but there are some real hard questions that we need to address. And this has been playing out quite a bit in New York, in a couple of examples in New York, but I thought I would give you some non-New York examples just to get you thinking about safe to fail. So my favorite example of this comes from Phoenix. And so this is an area in Phoenix in 1935. And you can see there's some ag fields there, and there's a stream. This is a desert stream called Indian Bend Wash. And desert streams are very flashy. They're dry most of the time, and then there's these huge floods. And so as Phoenix was converting this agricultural area into housing, they're like, okay, what are we going to do with the stream? And the fail-safe approach is you dig a big concrete trench and you bury the stream deep, deep, deep so that it can't flood. But then for this one, they said, this is a really flashy stream. And they said, maybe this isn't going to work. And so this is what Indian Bend Wash looks like today, or this is what it looked like in 2000. You can see lots of houses in Phoenix, but Indian Bend Wash is still there in a slightly modified form, in that they left the stream wide and they built a bunch of lakes to capture water. And basically they let this whole thing flood for a few days a year. So Indian Bend Wash is a lovely park for maybe 350 days of the year. And it's flooded for maybe 12 days of the year from a flood. This is a classic example of safe to fail. So where we're going to let the water come, we're going to minimize the consequences of the flood, and then we're going to let the flood water drain away carefully. And so Indian Bend Wash is to me is a good example of a safe to fail type of example. And the contrast is the Los Angeles River, right, which was a nice desert stream in 1900. And they had a bad flood in Los Angeles. I think it was either 1938 or 1942. And they said, okay, that's enough. And they built this enormous concrete channel. And the Los Angeles River is kind of an eyesore through the city. So the question is what are we going to have safe to fail in New York City? And I think we've really got to think about this, and we've made some progress on this already, because for one thing, there's a lot of things that the giant wall won't control. Even if you build a barrier across the harbor, think about Hurricane Ida, right? So it's almost like we were all looking out to sea, and then boom, the flood came from behind us. It came from the land, and so we're going to have to think about are we going to build a lot of walls all over the city, or are we going to come up with some clever ideas to minimize the consequences and maximize the recovery? And so we've already made some progress, right? So the water drains out of the subways much more quickly than it used to. We had backup generators during Sandy. They were all in the basement. They've been moved to higher floors. I'll talk a little bit about this idea of making blue spots, which are places to temporarily absorb huge amounts of flood water. But then there's a big role for these natural and nature-based features and green infrastructure, and also possibly managed retreat. But we'll see if I have time to talk about that. I wanted to highlight, when we think about this idea of blue spots, the work of Bernice Rosenzweig, who's a professor at Sarah Lawrence College, who's been spending a lot of time thinking about pluvial flooding, which is a term you may not have heard. Fluvial flooding is when a river overflows its banks. It rains in the mountains, the water comes down out of the mountains, and the river floods. Fluvial flooding is what we had with Hurricane Ida, where it just rained so hard that it exceeds the rate of infiltration that the engineered drainage can absorb, and so you end up with flooded streets, right? So this is a picture of Queens in January '99. So this idea, a concept that's emerged around the world, is the idea of blue spots. And are there places in our cities where we can temporarily store large amounts of flood water? Now you look at this Queens neighborhood, this is an area that kind of seems to naturally collect a lot of water. And maybe do we need, like Indian Bend Wash, to find places in our cities where we let them flood during large events, and we minimize the consequences of those flooding, and we maximize the return from those. This is kind of another kind of state-of-the-art place, but it's going to involve a lot of work with vegetation and parks and spontaneous vegetation and community science. And so this is, I threw this in here because it's another issue that I think that this group has a lot to contribute to. So there's blue spots. And the last thing I wanted to talk about was this idea of managed retreat, which is again another issue where people who think about plants and spontaneous vegetation need to think about it. So the idea of managed retreat is the idea that maybe there are certain places where people shouldn't be living, that we should abandon certain areas. We should move human development out of harm's way and restore these natural areas to enhance their ecosystem services. Now, this is an idea that's developed, again, with academics, and there's lots of good academic thinking about what kinds of planning and programs you need to facilitate managed retreat. There's some pretty good ideas about what conditions allow managed retreat to succeed. And again, as an ecologist, this is everything we hope for. Thinking about integrative approach and using natural processes to solve environmental problems. But managed retreat makes a lot of sense to me, but how's it going to play out, right? So I don't know if you all have thought much about managed retreat in New York City, but there was a bunch of it, in particular in Staten Island, where there were a bunch of neighborhoods where people were like, we don't want to move back. And this was a huge surprise, because most people's natural reaction to getting to a disaster is we're going to build back. We're going to build back better. We're going to come back. And there was a woman, Elizabeth Kozloff, who was getting her PhD at NYU, and she was studying the response of different neighborhoods to Sandy. And so she went out to Oakwood Beach in Staten Island, and she got up there and she saw that people were like, they were campaigning for the city or the governor to buy out their homes. And it was a real shock to her, because again, there's this idea that people always want to build back, but here was a neighborhood that had flooding problems for years, and maybe the idea was maybe we should retreat from certain areas. And again, this is super appealing to an ecologist in that we could reestablish a bunch of these natural ecosystems and get a lot of ecosystem benefits for it. But again, it's not so easy, because if we move, so let's take out how this plays out in Staten Island. So I now abandoned whole neighborhoods. I used to collect property taxes in those neighborhoods. Now, not only am I not collecting property taxes, but I have a bunch of vacant land that I have to manage. And so from a municipal finance point of view, managed retreat is very problematic, because you lose tax revenue and oftentimes very valuable tax revenue, because the coast is very valuable property. And then of course, there's a question of how do you make these decisions? There's a lot of people living in areas that are susceptible, vulnerable to flooding in New York, and who's going to make the decision to stop rebuilding and when? And so managed retreat again is another example of an academic concept that makes a lot of sense, that's very exciting, but we got a lot of work to do before we're going to make it happen. Okay, so a couple of conclusions and thoughts to leave for you. This is it's an exciting time to be anywhere in environmental science, whether it's plant science or landscape design or ecosystem ecology. It's an exciting time because society is turning to us, and with great interest in green infrastructure and other soft approaches to build resilience, to clean the air, to clean the water, and to improve the quality of life for people in these different neighborhoods. And so it's an exciting time, but boy, there's a lot of work to do. If we're going to really understand the reliability of green infrastructure and how well are we going to deliver on these promises, there's a lot of work to be done. And again, the questions are, is it going to work? Is one question, and that I can answer in an ecological or technological framework. This question of, do people believe it's going to work? That's a different question. That's more of a social science question that requires a different kind of analysis. Community science that you all are interested in is really at the core of that. And we need to be able to tell if it's working. And I tried to give examples. It's really hard to tell if these things are working. Are they working in multiple ways, and are they working over time? And then ultimately there's the equity piece. Is it working? Is it working for everyone? So I think it's an exciting time, but we've got a lot of work to do that I'm hoping is going to keep many of us busy for a long time. And I thank you for your attention.